Welcome to the Rhythm Tree tutorial series, created by the junior high band teachers of the Gilbert Unified School District in Gilbert, Arizona. Rhythm Tree tutorial number 4, Visual Representations. At the end of this tutorial, you should understand the mathematical breakdown of note and rest values from whole to 16th, the meaning of subdivision, and how the rhythm tree and other examples visually represent musical subdivision. To be successful, you need to already understand the concepts taught in these earlier tutorials: Rhythm Tree Part 1, whole and half, Rhythm Tree Part 2, quarter and eighth, and Rhythm Tree Part 3, 16th. The first 3 tutorials in this series showed that notes make sound and rests are silent. They also showed that notes and rests of the same type get the same number of beats. The analogy of a rhythm tree helped explain the relationships between different note and rest values by picturing them as leaves on a tree. Starting from the whole, worth 4 beats, the tree branched out into more leaves of increasingly smaller values: half, worth 2 beats, quarter, worth 1 beat, eighth, worth a half a beat, and 16ths, worth only 1/4 of a beat. This final tutorial of the series reviews the mathematical division of notes and rests from whole to 16th. It concludes the rhythm tree analogy by providing visual examples of those relationships. Now let's review the complete mathematical breakdown from whole to 16th. We start with the whole, worth 4 beats. It's the whole amount. A whole note gets 4 beats of sound, and a whole rest gets 4 beats of silence. The half is worth 2 beats because it's half of the whole. So a half note gets 2 beats of sound, and a half rest gets 2 beats of silence. A quarter is worth 1 beat because it's 1/4 of the whole. So a quarter note gets 1 beat of sound, and a quarter rest gets 1 beat of silence. An eighth is worth 1/2 of a beat. That's 0.5 of a beat because it's 1/8 of the whole. So an eighth note is worth 1/2 a beat of sound, and an eighth rest is worth 1/2 of a beat of silence. Then we split the whole into 16 parts. A 16th is 1/4 of a single beat. That's 0.25 of 1 beat because it's 1/16 of the whole. So a 16th note gets 1/4 of a beat of sound, and a 16th rest gets 1/4 of a beat of silence. When notes or rests split into smaller parts, it is called a subdivision. An upside-down rhythm tree is one way to visualize subdivisions. This upside-down rhythm tree uses single eighth notes and single 16th notes. We start with our whole note. The whole note can then be split or subdivided into 2 half notes. It takes 2 half notes to equal 1 whole note. Each half note can then be subdivided into 2 quarter notes. So it takes 2 quarter notes to equal 1 half note, 2 halves to equal a whole, or 4 quarter notes to fit into 1 whole note. Each quarter note can then be subdivided into 2 eighth notes. So it takes 2 eighth notes to make 1 quarter, 2 quarters to make a half, 2 halves to make a whole. We could subdivide 1 whole note into 8 eighth notes. Finally, each eighth note subdivides into 2 16th notes. So it takes 2 16th notes to make 1 eighth note, 2 eighth notes to make 1 quarter note, 2 quarter notes to make 1 half note, and 2 half notes to make a whole note. The whole note can be subdivided into 16 16th notes. This upside-down rhythm tree uses beamed eighth notes and double beamed 16th notes. It's really the same exact thing. We're just going to group our eighth notes and our 16th notes together. We start with our whole note, subdivides into half notes. The half notes can then subdivide into quarter notes. Now each quarter note is going to subdivide into 2 eighth notes. We can beam together the 2 eighth notes. They don't have to be shown as individuals. We could also group 4 eighth notes together, but it still means that 1 quarter note subdivides into 2 eighth notes. We've just connected 4 eighth notes together, which would equal 2 quarter notes. Each of our eighth notes can then be subdivided into 16th notes. Each eighth note breaks into 2 16th notes. But here, instead of showing individual 16th notes, we're just pairing them together with double beams. Here's what it would look like if we put 4 16th notes together with the double beams. It doesn't change the value of the 16th notes. If you count just the note heads of the 16th notes, you'll see that there's still 16 of them there. Now let's take a look at rests. This upside down rhythm tree uses 8th and 16th rests. We start with our whole rest. Just like the notes, we can split the whole or subdivide the whole into 2 half rests worth 2 counts each. Each half rest splits into 2 quarter rests, so it takes 2 quarter rests to equal 1 half rest and 2 half rests to equal 1 whole rest. Or we could think of subdividing the whole rest into 4 quarter rests. Each quarter rest subdivides into 2 eighth rests. So it takes 2 eighth rests to equal 1 quarter rest, 2 quarter rests to equal a half rest, and 2 half rests to equal the whole rest. The whole rest can be subdivided into 8 eighth rests. The last step is that each eighth rest subdivides into 2 16th rests. So it takes 2 16th rests to equal 1 eighth rest, 2 eighth rests to equal 1 quarter rest, 2 quarter rests to equal a half rest, and 2 half rests to equal a whole. Or we could subdivide the whole all the way down to 16ths, and it would take 16 16th rests to equal 1 whole rest. Remember, rests cannot be beamed or double beamed. Here's another way to look at it. This is a linear subdivision of the notes. So it's a breakdown of the note values from left to right. We start with our whole note, and now we can see left to right what it would look like when it splits into 2 half notes. Each half note subdivides into 2 quarter notes. The quarter notes subdivide into eighth notes, and the eighth notes subdivide into 16th notes. You'll notice that the eighth notes are beamed together into groups of 2, but if you count the note heads of the eighth notes, you'll see that all 8 of them are still there, and that our 16th notes are double beamed together into groups of 4, but if you were to count all of the note heads of the 16th notes, you would see that all 16 are still there. So let's look at the linear subdivision of rests. So it's a breakdown from left to right. We start with our whole rest, subdivide to 2 half rests, 4 quarter rests, 8 eighth rests, and 16 16th rests. Still another way to take a look at the visualization of how notes and rests can be split is to think of it as a pie. We start with a whole pie. That would basically be our whole note. Just like you could take a whole pie and split it in half, we can take our whole note, cut it down the middle, and have 2 half notes. If we had a whole pie and we made 4 equal slices, it would be the same as if we took our whole note and we divided it or subdivided it into quarters and have our 4 quarter notes. Here we have our whole pie, and we're going to cut it into 8 different slices. And if we took our whole note and we subdivided it into 8 equal parts, we have our 8th notes. We take our whole pie and divide it into 16 equal sized slices. That would be the same as if we took our whole note and we subdivided it into 16 16th notes. So why is it called a rhythm tree? Well, here's a graphical look at the subdivision breakdown. We start with our whole note, subdivides into half notes, then quarter notes, and so on, 16ths and beyond. But flip it back over and it becomes a tree. Ta-da! The whole note grows up into half notes, quarter notes, 8th notes, 16th notes, and even beyond. This tutorial showed that notes and rests of the same type get the same number of beats, and that notes make sound and rests are silent. It employed the analogy of a rhythm tree to define and show the subdivision relationships between note and rest values from whole to 16th. It also provided other visual representations of the subdivision concept. This concludes the rhythm tree tutorial series.